So today and tomorrow I'm going to talk to you guys about different ways that math and music can go together. When you guys think of math and music, what are some things that come to mind? Chords, okay.
Progression.
Progression, yeah. About physics of it. Frequency, yeah. Wavelength, frequency, resonance, harmonics, the overtone series. There's a whole history of the use of math as a composing tool. I'm going to talk about serialism, assigning notes different numbers. Instead of thinking about keys or different tonal centers, you just about them as numbers and do operations like transformation and addition. First, I was going to show you some different examples of loose relations of math. This is something I wrote about. It's a mathematical object. So if you know what it is, you can shout it out at the end. I don't know much about land and sea. Don't know much about dimension Z. I don't know much about the right-hand rule. Don't know what volume is for. But I know if you got me times two. It's non-oriented. There's only one side, so there is no inside or outside. And anyways, that was just a little warm-up. I'll play you an example that's called uniform convergence. Two functions like approaching something, they get there at the same rate or at the same time. Like somebody give me an example of a function. Okay, x squared. So we've got x squared like this. And then let's say you take negative x squared. You could loosely consider that these two things are uniformly converging towards each other. I wrote a composition that relates to that idea of two functions coming together in a evenly spread way. Coming up. One's coming down, one's coming up. It'll happen again.
Baseline walking up and down.
Okay, good.
Lots of ostinato together.
Right. The main place where the two come together is when the bass line is going chromatically up, and I think the saxophone is doing it also, and the tenor saxophone is playing a chromatic scale coming down. I'll play you a traditional Chinese song called Jasmine Flower. Different arrangements of this tune and related them to like different knots. A knot is, imagine taking your headphones or your shoelace. You take the two ends, you twist them up however you want, and then you close them. You can pass it around itself, you can't cut it, and you can't intersect it with itself. So they're basically like a more complicated circle. A knot is just another mathematical object. They're like algebra, X. You can think of knots just like you would think of numbers. There are prime numbers, there are composite numbers. Okay, prime number means you can't divide it by anything other than one in itself. A prime knot is the same thing. It's the simplest knot that's possible that looks that way. Like you can cross and uncross, you can slide under a crossing. So if you do any of these three things, it's considered the same. And by the same, we mean, do they have the same number of crossings in the same place? Can you make one look like another just by sliding the parts around? If you add a circle to any other knot, it's the same knot. So in that sense, it's considered a knot, but it's like the simplest prime knot that you could get. If you imagine that Jasmine Flower is the base, the unknot, or the circle, I made different variations. The first one might be trefoil. It's the prime knot with three crossings that we looked at. In my arrangement, I basically divided up the measure into three attacks. Three iterations of a rhythm for every two measures. So 1, 2, 3, 4, right? Here's the twos. We're in 4, 4, 1, 2, 3, 4. But you can already tell there's three attacks. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 4. It's technically not a quarter, and then quarter. what a trefoil knot looks and kind of feels like and incorporate it into that arrangement. 3 attacks over the measure of 4/4. Question?
When you're saying that's like a group of 3 and a group of 2, what is actually being 3?
If you wrote it out musically, your quarter notes are being grouped. We're in 4/4, and the rhythm really was like, this is 3/8 notes, this is 3/8 notes, and this is 2/8 notes. 1, 2, 3, 4. Da 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 da.
Can you try to conduct while she's playing so you can feel it better? 1, 2, 3, 4. Down, in, out,
Play C, D, E, A. So try to play any combination of those things, but in this This way of composing that I'm going to show you is much more mathematically rigorous. Okay, instead of thinking about notes as letters, what composers did at the time was they gave them all numbers. So C is 0, C sharp is 1, D is 2, and you can do calculations with them. So this is a way of weighing all the notes sort of equally. This is like mod 12 math. It's like counting on a clock. All the numbers below 12 just stay as they are. What's 15 o'clock? 15 hours is really great. So in mod 12 math, you have 0 through 11, but then 12 becomes 0, 13 becomes 1, 14 becomes 2. How do you figure this out?
It's like remainder, right?
Yes, you figure out what the remainder is. 23 mod 12 is what's the remainder when 23 is divided by 12. Yeah, what's 52 mod 12? 12 times 4 is 48. So we have a remainder of 4. What happens if I do 61 mod 12? You do 61 divided by 12 is 5 with a remainder of 1. When you do addition, do the addition first. So 5 plus 10 mod 12, that's really like what is 15 mod 12? 3. So you get 3, okay, good. And then 100 minus 35 mod 12 is 5. So there's 2 main operations, transposition and inversion. So basically, transposition is taking one thing and playing it in another key. So since you're listening to Jasmine Flower, I'll play it in one key. And then in another key it would be. The relationship between the notes is the same, but you might start on a different note. That's the same as mathematical translation. You have a graph, you can shift it up, down, left. Tn equals x plus n mod 12. That's the transposition formula. Can you take a lullaby like Twinkle Twinkle Little Star and represent it as the numbers, not the letters?
4, 4, 2, 2, 0.
Good. Okay, so now we're going to transpose by whatever interval you want. The formula is you add the original note with the amount of transposition, and then you do it mod 12. Let's add a number. 7, you want to do 7? Okay, so what's 0 plus 7 mod 12? So this goes to 7, 7. Now what does this go to? 2, yes.
2, 4.
Now let's give me the letters back.
It's 14.
We're like, okay, we're going to take our function and shift it up 7. What is that musically? What interval is plus 7? So everything goes up a perfect fifth. So I'll just play you the original. And then the transpose one up a perfect fifth is. Here, why don't you guys make up a melody, give me some numbers, or if you want to do something that you know. Okay, so like somebody pick an interval. 6. Okay, how wide is 6 half steps? This is going to go to 10, right?
Yeah.
So what's 10?
B.
B flat, B flat. So this is B flat, and this is E. So how wide is an interval from E to B flat? Is it 3? Yeah, it's a perfect fourth plus what? Right? So you have E to A is a perfect fourth, plus another half step, so that's an augmented fourth, or a tritone. Plus 6 isn't a major sixth. That's the key distinction here, right? Like plus 8 is not an octave, you need to do plus 12. 4 goes to 10, 5 goes to, 5 plus 6, 11. 7 plus 6 is 13, 13 mod 12, 1. Okay, good. So somebody tell me what these notes are. What's 11? B, good. 1.
C sharp.
We're going to transpose it up in augmented fourth. I'll play the original one, then I'll play the transposition so you can hear it. you play with me an example? Same notes, but a different note is on the top. Here, this is like mathematical reflection. You thought about this as a graph. You reflect it over a certain axis. Here's my stack, and let's say I have some notes. If I take this set of notes and reflect it over an axis, I would reflect it going down. This would become A, and so on. Inversion you can think about as reflection across an axis. You can invert around a pitch axis, meaning a note, a particular note, or you can invert the actual intervals. Let's say you've got 0, the note C. I'm going to arbitrarily choose to invert around F sharp, which is 6. To get the inversion of C around F sharp, you do 6 minus 0 mod 12. 6 minus 0 is still 6. What if we inverted around 10? Using this formula, n minus x mod 12, where n is the amount of your inversion and x is the original note. The note 10 goes to what? 6 minus 10 is negative 4. Negative 4 mod 12 is 8. Transposition preserves what the melody sounds like, but when you do inversion, it doesn't sound the same. Why don't you guys do Twinkle Twinkle, and let's just invert around 10. 10 is flat. X is the note, N is the transposition, so it's going to be 10 minus 0 mod 12. This one's going to be 10 minus 7 mod 12. My question for you is this going to sound the same as a little star? No, why not? It's not going to sound the same. Yes, every time you go up in the melody, you go down in the inversion. So we all remember the original one. The original melody. Now it's going to sound totally different. It's not. So you can really see that it's a reflection. F sharp is this note. So then I have D, which is here, C sharp. If you kind of drew it like this, you could kind of see that this is the same, but reflected over that note.